In this video, I'm going to show you how to sketch a graph operational function. So with me, I've got this example that says f of x is equals to 3x squared plus 3, everything all over x squared minus 9. So the first thing we're going to do is try and find out the first derivative. So we have, if we try and solve for this one, we get minus 60x all over x squared minus 9, everything squared. So that will be our first derivative. Then we go on to the second derivative, and we get this one using the first derivative. So basically it's just the same step. And we're gonna get 180 open bracket x squared minus 3 close bracket, everything all over x squared minus 9, everything cubed. So the first derivative and the second derivative, we're gonna need it when we going to sketch our graph. So as for now, let's go on to find what our intercepts. For the intercepts, in this case, we only have one, which is when x is equal to 0, we get y is equal to minus 1 over 3. So that will be the only intercept we have here. Then for the asymptotes, we get the horizontal and the vertical. To get the horizontal, we just have to say as x goes to infinity, what we have. In this case, we're gonna have 3. As x goes to infinity, y approaches 3, but it never touches the line y is equal to 3. Okay, so to find this, we all have to do is just have to take out x squared in both the denominator and the numerator. Then with that, we're gonna left with inside the brackets, we're gonna left with 3 plus 3 over x squared all over 1 minus 4 over x squared. You know, like a small number over a number to infinity is what? It's 0. So that will bring us to 3. So as x goes to infinity, y is equal to 3. Then to find the vertical asymptote, just have to equate the denominator to 0. So in this case, it's x squared minus 3 is equal to 0. Then we solve it, we're gonna get x is equal to plus or minus 3. Then for the points of inflection, we just have to equate the second derivative to 0. Then we're gonna get x is equal to plus or minus 3. Okay, we go back to our first and second derivative. This is where we're gonna need them. So we have to find like where the function is increasing and where it's decreasing. So to do this, we just have to test like a certain point, you know. So they start with the positive side of the graph. So from 0 to infinity, and see like how it goes. So to do this, we have to find the f of x at a certain point. So f of x at 0, we know that f of x at 0, it will be minus 1 over 3. So in this case, our graph is decreasing. Then that also applies for 2 and x is equal to 3. Then from x is equal to 3 going onwards, the graph is still decreasing. So we know like from 0 to infinity, the graph is decreasing. Then let's find out for the other side of the graph where x is less than 0. So from here, we can see that f of x at minus 1, the function is what? The function is increasing as our f of x is greater than 0. So as we go on like minus 2, minus 3, the graph is still positive. So that means that it's increasing, like from infinity to 0, the graph is increasing. Then now to find out the concavity of the graph, we have to look at the second derivative. So to look at the second derivative, we have to see like when the second derivative is less than 0, then we know that our graph is concave down. And when the second derivative is greater than 0, then our graph is concave up. So in this case, we're gonna have f of x less than 0 for x greater than 1, greater than 2, greater than 4. But at 3, it doesn't, it's not defined since we have like a horizon, I mean a vertical asymptote when x is equals to 3. So at this point, 3 doesn't exist. So going again to the other side of the graph, then we're gonna have a concave down for x is equals to minus 1, minus 2, then at 3 doesn't exist. Then the graph is also concave up at minus 4, minus 5 going to infinity. So basically, between the region minus 3 to 3, our graph is it's concave down. Then between 3 and going on to infinity, our graph is concave up. That also applies the same thing from minus 3 going to negative infinity. Our graph is also concave up. So basically, when you try to draw this thing, it's gonna look like that. And also notice that our graph from point 3 going to infinity, and also from minus 3 going to infinity, x is equals to 3 going to infinity. Our graph never touches the line x is, I mean y is equals to 3. This is a horizontal asymptote. So we're gonna try and sketch it like using all this data, and we're gonna have something that looks like this.